Look at this automotive test result. We have an ECU, test case, status, duration, and an error. That's a lot of related information. Today we're going to learn how Python can keep all of this information together using a dictionary. A dictionary stores information as key-value pairs. ECU is our key, ADAS is its value.
Let's build our dictionary. We open with a curly brace. Then each piece of information gets a label called a key, followed by a colon, then its value. ECU, others. Test underscore case, TC underscore 102, and so on. Unlike a list where we find things by position, a dictionary lets us find things by name. That's a much more natural way to represent something like a test result, where each piece of data actually has a meaning.
We now have the complete test result in one Python object. But how do we retrieve just the information we need? For example, how do we ask Python, what ECU failed?
To pull a value out, we use square brackets with the key's name in quotes, not a position number like we did with lists. Test underscore result bracket. ECU gives us ADAS directly. We can combine two lookups in one F string too. Test underscore result bracket ECU arrow test underscore result bracket status, giving us ADAS to fail in one clean line.
One dictionary can represent one test. But remember yesterday? We had multiple test cases. Let's combine the two concepts and create multiple structured test results.
Now let's combine everything from this week. Tests is a list, just like day 2, but instead of holding plain strings, each item is a full dictionary, just like the one we just built. When we loop through it, each test in the loop is one complete dictionary. So inside the loop, we can pull out its ECU, test underscore case, and status by key exactly the same way. This is structured data, 3 complete test records, each one self-describing.
Now our data looks much more like something you'd actually find in an engineering system. But so far, Python is only displaying the information. Tomorrow, we're going to make Python think in terms of rules. For example, if the temperature is too high, raise a warning. If the battery voltage is too low, flag a problem.
Let's pull one specific record out of our database. Tests bracket 1 grabs the second item in the list, using the same indexing we learned on day 2. And that item happens to be our ADAS test that failed. Once we have it, we access its fields exactly like before, by key. This is the beginning of structured engineering data handling. One line to find the record, then clean, named access to everything inside it.
One more thing worth knowing. What happens if you ask for a key that isn't actually in the dictionary?
One more thing worth knowing about dictionaries. Square brackets work fine when you're sure a key exists. But if you ask for a key that isn't there, Python crashes with an error. .get function is the safer option. It takes the key, plus a second value to fall back on if that key isn't found. Duration exists, so we get 18 back. Mileage was never stored, so instead of crashing, we get not applicable, our fallback value.
You can also check whether a key exists at all before trying to use it, using a simple in check.
You can also check whether a key exists at all before trying to use it. Error. In test underscore result asks Python a yes or no question. Is this key present in the dictionary? In this case, we never stored an error key on this particular test, so the answer is no, and we print our fallback message instead of risking a crash.
And when you want every key and value at once, you can loop through both together, not just one or the other.
Last one. Earlier, we looped through a list of dictionaries, but what if you want to loop through everything inside one dictionary? .items functions hands you both the key and the value together every time through the loop. For key, comma, value, intest underscore result dot items, colon, prints every single field this test result has, all 5 of them, without us naming a single one by hand.
Today you learned dictionaries and combine them with lists and loops. Tomorrow we're going to introduce conditions and make Python start making engineering decisions. If this helped, subscribe to our channel. It's free. Share it with someone who needs it. Code's in the description. See you tomorrow.